Okay, let's get started. Okay, so as I just mentioned a little while ago, connect to Laulima, the resources, and then we're going to go to the daily work folder and open up the folder that has today's date, February 25th on it. And there's a couple of files in there, the HTML file, which goes over what we're going to be covering today. And then there's also a Python file in there that you can download, so you don't have to type that out. Okay, so I'm going to open up the HTML file, and then let's take a look at this. Okay, so a couple of things we want to work on today. We want to work on project 1, get some more work done on that. And here, let me just click on the project 1 PDF file, so we can bring that up as well. Okay. And then we're going to be looking at SHA-512 hash. There's a very simple Python program. I typed it out there, but you can just get the one that's in the folder and just download that. And what I did, this notation, that I put here, I just put main Docker folder there, but that's the one that says Docker-CENT280-Win7. Okay, but from that folder, the docs folder, we're going to go into the project 1 folder. Remember, that folder is outside of the web document root. Okay, so it's something that cannot be broadcasted by Apache, right, in order to, so you can't see stuff in there. And that's because that folder has sensitive information that you wouldn't want to be viewable using Apache. Okay, so what I'm going to do is go to Windows Explorer and then go back to this folder here. Okay, so Windows Explorer, start off in Documents, then Docker, then our main Docker folder, right, the Docker-CENT280-Win7. And inside of there, I want to go into the Docs folder, and then we have this Project 1 folder, which we created previously. That has helpers.php. We're going to be looking at that today in a little bit. And what we also want to do is we want to create the folder, the file testhash.py. And actually I decided last minute to just upload a copy of that so you don't have to type it out. So I'm going to right click on this and go choose Save Link As. And then I want to put it inside of that folder that we were just looking at. So inside of the docs folder, project 1, that's where we're going to put it. Okay. So this is a folder that gets mapped into the Postgres SQL container when we start that up. And then so we want to just go ahead and take a look at that. So I'm going to minimize the browser here. And I'm going to start up a conemu terminal. Okay, and as usual, the first thing I do is set the environment variables so that I can run the Docker commands. And since we're going to do stuff both on the Python side, the Postgres SQL side with Python, and also we're going to be looking at some PHP scripts, so we need to have a connection to the PHP Apache container. I'm going to open a second conemu terminal and then set the environment variables for that. And in one of the terminals, I'm going to switch into, or actually both of them, I should switch into the main Docker folder. And then in one of them, I need to start up the Docker containers. Okay, and then what I'd like to do is to start off, since I'm going to be looking at the Python script, I'm going to go into the Postgres SQL container, because that's the one that has the Python tools. Okay, so let's do that. Okay, so Docker compose, I'm going to run execute Postgres SQL container. I'm going to run the bash, so I get a terminal there. And then once I get into that, then I want to change into the project one folder inside of docs. Okay, so if I do cd/home/docs/project1, oops, what happened there? Oh, sorry, that is docs. Sorry, I got to change into project one because docs gets mapped to home. Forgot that. Okay, so I should have said cd/home/project1, and then that would have been the correct command to get into this. Okay, so I'll do a ls just to make sure that I'm in the correct directory, and because I had downloaded test_hash.py, I can go ahead and run that. And then what you see as a result of running it is two SHA-512 hashes of some text strings. Okay, now let's go back to Windows Explorer and open this file using Genie. And we may have a lot of stuff there. I forgot if we have a lot of, no, I guess I closed all of mine. Okay, so let's take a look at this. Okay, so the first thing we do is we import the HashLive module, okay, so because that's not part of the built-in functions. And then what we're going to do is we're going to, from the HashLive module, run the SHA-512 function. Okay, and in the SHA-512 function, when you pass it a string, you need to make sure that that's a binary string, and that's what this little b here is before the quotes around it. Okay, so that's test, but it's passing it in binary form because that's what is required for the SHA-512 function. And then after you return that, then it calls hex digest on it to make it show up as a hex string. So if I look back at the terminal, okay, this is a hexadecimal string. Okay, and it stretches out to there. And so when I take test, T-E-S-T, all lowercase, okay, and I take the SHA-512 hash of it, then this is the resulting hash. Okay, that's what it looks like. Now if you look at this other hash, you can see that it's the same length, right? This hexadecimal string, same length, but if you look at the code, that was for a different string. Okay, so instead of this, which is just these 4 letters, T-E-S-T, this one is a much longer string. Okay, so if you go back to Laulima and you're looking at this, it's asking, is the length of the password directly related to the length of the hash? Well, Here this password is 4 characters. This one is a lot more than 4 characters. Okay? And when you look at the result, the hash is different because it's a different string, but they're about the same length. I think it's exactly the same length in characters. So this, when you look at this, should make you very suspicious of sites that have a limit on the length of your password. Okay? Now it could be the person who set that up, they're just trying to sort of be nice to you, and they figure that if you make your password too long, you're never going to remember it. So you might write it down or something, which is a very bad idea. But it could also be that what they do is they store the stuff where there's an absolute length, right, requirement for how long the passwords can be. So they're storing it as clear text using varchar or something like that in their database. And that's why they're concerned with the length, right? If we store something that's hashed, we don't care what length the original password is, because once you hash it, it comes out about the same length anyway. Okay? So it wouldn't even make sense in a properly designed database that stores passwords to limit the length of the password. Okay? And so there's been a number of sites where people recognize that, oh, in setting the password, you're limited to a certain number of characters, and in the follow-up to that, they found out that many of them were storing their passwords as clear text, and then a lot of them changed as a result, so that's good. But anything that at today, if I were signing up for something and the password, it said no more than 16 characters or something, then I would be very suspicious. Okay? So, in fact, it would question me as to whether I really want to have that kind of an account or not. All right, so if I run the program again, and you bother to look, you would find that you get exactly the same string, right? You do a SHA-512 hash, you're going to get the same result, but it's a one-way type of algorithm. So I cannot go from this and come back to test, or this right here, and then come back to that very long password. Okay, it's a one-way type of thing, and that's on purpose. Okay? Because if it's encrypting, which is two-way, so if you have the decrypt key, you can go back. If someone gets a decrypt key, and what you have stored is all these encrypted passwords, then you can get all the passwords back if you have the correct decrypt key. With a hash, you can't do that. Okay? Although, the way that a lot of times they use programs, okay, like John the Ripper and things like that, to basically crack passwords, they use rainbow tables, and it takes into account that the hashes are just one directional, right? So you get a text string, get the hash value of it, okay, that cannot go back to original text string. However, rainbow tables, what they try to look for is some string, okay, which is capable of producing the same hash value. Okay, because these hash values, okay, even though it's one directional, it doesn't mean only one text string could have resulted in that hash code. Okay, so that's what rainbow tables are based upon. So yeah, let me talk about rainbow tables just a little bit, because you folks are in CENT and concerned with security. You might think in designing a rainbow table, what they would do, and this is the way I saw it originally described, is basically they come up with a whole bunch of different strings, okay, and they compare the hash of that with whatever hash that they've been able to find, because they're trying to crack that code, and then when they find a match, then they look, oh, it was this text string that produced that. Okay, it's not, they don't do that, and the reason for that is because that would require storing so many different text strings that it basically would not be feasible. Okay, or if you made one, it would solve such a limited number of passwords, it would not actually work. So what they do instead is they have something called a reducing algorithm. Okay, so they take strings, okay, so they basically they reduce this hexadecimal string by some kind of algorithm. The algorithm could be complex, it could be very simple. It could be take the first 10 digits in the what you find. Okay, so it skips the B, then it goes 3, 5, skips the D, so 3, 5, 1, okay, 0, 9, 4, 0, 5, 5, and until they get 10. And that's the reduction algorithm. Okay, then what they do is then they perform the same hash on it, so do a SHA-512 on the reduce thing, okay, and then they store that information. Then they perform the same reduction algorithm. Okay, and then they take the first 10 numbers again, first 10 digits that are not alphabet letters, or the first 10 alphabet letters, whatever they decide to do. Perform it over and over, and then what happens after a while, they're going to get to some point where in the stuff that they generated, they're going to get a hit, and they've got to work their way backwards, and they can figure out what the original text string could have been in order to produce that. Yeah, go ahead.
So when we're logging in, we type it in clear text, and then when it
What happens, yeah, very good. So when you log in, you type in clear text. So the thing that does the authentication will perform the same hashing, and actually a salt and a hash that was done originally. Then it'll compare it to the encoded password, which is the salted and hashed, and if those match, then it authenticates. Okay, so if somebody gets a hold of the database and gets hold of all encoded passwords, since they don't know how that was generated, there's no way to get the original one. In fact, there's no good way to do it anyway, except with a rainbow table, if you had a rainbow table that matched that, because it's one way. Yeah, so it's not like, oh, I got this, and if I know exactly how it's generated, I can go back to the original text. Can't do that. So they use rainbow tables instead. Okay, so rainbow tables basically will consist of storing those reduced versions, right? Those whatever they use as a reducing algorithm, it stores that, and then of course it's still very large, right? Those rainbow tables, if you get like some of those larger sets of it, I mean several gigabytes, right, just to store the reduced versions of that. And that's also why a lot of times when you have rainbow tables, the ones that are more effective is if the hash that was used was something like MD5. Okay, because MD5, the length of the unshortened string is like 32 characters. Okay, not like this. Okay, so SHA-512, it's pretty hard to break stuff that way. Okay, so we're going to talk about how in addition to hashing it, we're going to salt it. And then when you salt it, then that basically improves the complexity, makes it that much harder to come up with rainbow tables that will actually give you the correct result. And actually, if you ever have had a chance, or if you haven't had a chance to, you should download John the Ripper and then try it for just simple passwords. It's quite remarkable how quickly it'll find simple passwords. You'll find what it was. Okay, and then go ahead, if you have access to some Debian-based Linux, okay, just the regular passwords that you store for the users on Debian Linux, and you try to run it on those things, you'll find that even if the original password itself were very simple, like Jane for Jane Doe, it'll take you, you can try it. It depends on how long you're willing to wait, but I've tried running it for a week and it couldn't figure out that password because it's salted and hashed. Okay, so we're going to get some feel for that. Okay, so this doesn't exactly give you a great feel for it, but what it tells you is if I perform SHA-512 on this versus this, I get stuff that's equal in length but looks nothing like each other, and there's no way to directly go backwards and find out what the text was. But that's why, to be careful, if this were on a server that people have some public access to, this is why you put it outside the web document root, because you wouldn't want the clear text password someplace there, right? We say, oh, that's what the password must have been in order to set this. Okay, so that's something to keep in mind. Now, so that's just a simple Python program, but we're going to be using PHP. Later on, we're going to be using something, a language that's internal to PostgreSQL, okay, PGSQL, PLPGSQL, sorry. And that has its own ability to do SHA-512, and we'll use that as well, so that when you take CENT285, those of you who are going to do that, you'll have had a little bit of experience with that. Okay, so there's a link here. This is from the CENT280 website, and it's partway onto that page, and it's on salted and hash passwords. So in PHP, okay, there's a function called hash that allows you to perform a SHA-512 hash, among others. So when you look at this part here, that tells you that it's doing a SHA-512 hash as opposed to SHA-256 or something like that. Okay, now we're gonna make a function called doHash. Okay, and remember in PHP, all variables start with the dollar symbol. So this is just saying if I pass some text to the doHash function, it's going to perform a SHA-512 hash on it and return on it. That's all it does. So when we call doHash, it just does a SHA-512 hash. Now, we're going to also create a function called makeSalt. And so when you pass a password, it's going to generate a salt. Okay, so when you generate the salt each time that you set a new encoded password, that means the salt is randomized. Okay, so what is a salt? It's basically some text, yeah, that you're going to add on to whatever text you have for the password. So you concatenate it, and then you do the hash of it. That makes it harder, right, to figure out, because here's the person's password, here's a salt. Let's say we do a very simple salt, so it's just some other text, right? So we just say, oh, you know, my favorite fruit is pineapple. So then I take their password, I concatenate it with pineapple, then I do the SHA-512 hash on it. That's harder to break already, right? Because it's not their password, right? That's just their password that's being hashed, but it's the concatenation of these two. If you make this hash random, I mean this salt random, then it's even harder to come up with it, okay? And so, as far as I can tell, in Ubuntu Linux, that's what they do. It's not just a salted and hashed password that they store, but the salt is also random. So they use something to make it random. So how do we make ours random? It's actually pretty simple. You just use the time function, which basically gets the current date and time out to the nearest second. It concatenates it with their password, and then it does a SHA-512 hash. Okay, so the salt, okay, is already a SHA-512 hash that's random because it uses the current time, okay, concatenated with whatever their password is. Then so we take this thing, right, which is a SHA-512 hash of something which is randomized because it uses the current time, okay, and date, okay, so not just time, but date and time. And then we concatenate that onto their password, and then we hash it again. So it's doubly hashed with a random salt. That's basically what we want to do to make our encoded password. Okay, so here's what we're going to do. We're going to go back to Windows Explorer, okay, and see this helpers.php. We're going to add those files, right, because this is a PHP script. We're going to add those functions, sorry, into this script. Okay, so I'm going to open this, okay, and return back to this page right here. And I don't need this part here because that's just the starting tag for PHP. But what I want to do is grab all of these functions. So I'll go Control C and paste it in right here. Okay? So now I have do hash, make salt, make encoded pass, and those are three functions that we can use to make a salted and hash password. Okay? So when we actually do make encoded pass, because it's making use of the make salt function and the do hash function, it's a doubly salted, doubly hashed, random salted password that we come up with. Okay, so it's not super hard to write this code. It's actually pretty easy, but it would be very hard to create rainbow tables that would be successful when you employ a scheme like this. Okay, now, in reality, right, even if I store my passwords that way, all it does is it makes it very hard to use something like John the Ripper to basically crack the password, right? But in practice, the password could easily be broken if somebody just chooses something very simple, right? So if my favorite fruit was pineapple and I just chose pineapple for my password, okay, even though it's going to generate a random salt with that and then concatenate on the password and then it's going to do another SHA-512 hash on it, the hashed and salted text that I see doesn't even look anything like pineapple. To go from that and figure out what's pineapple would be very hard. But if you knew my favorite food is pineapple, you might guess, oh, maybe he put down pineapple and they just typed it in, they might get it, right? Or the other place where it can run people into trouble nowadays is people are starting to become aware that you shouldn't just choose a simple password like ABC123, okay, which was chosen by an incredibly large number of people. The reason why they chose that was the site says the password should be at least 6 characters and you should choose 3 letters and 3 numbers. Okay? So then they go, okay, ABC123. In one site that had over 1 million users, I forget which one it was, fairly popular one, 20% of the people, that's what their password was. Okay? So you could have got into 20% of accounts just by typing that in. Okay, other kinds of stuff, P with the @ symbol, then SSWORD, that's another one. Stuff where instead of letters like E, then they put a 3 instead, stuff like that. Those, again, a lot of people use those. A lot of people, of course, it gets broken into very easily. Okay, or the other thing is people go, oh, I better not choose a real simple password. So they make up a complex one, and they can't remember it. So then they write it down, right? And then worse, they put it on a Post-it note and they put it on their computer, right? So all those things defeat this kind of stuff. All you can do is say, if a user enters a password, I'm going to store it in a way so it will be hard from what is stored to go back to the original one, right? And that's all you can do. Okay, so when we employ stuff like this, okay, then we have to take control of 2 more things. And so we're going to look at that today a little bit and work on it. And one is you got to store things properly, and you got to know exactly how you stored it so that you can make a function that checks to see if the person actually entered the correct password. Okay, let me repeat that, right? You gotta add the user, right, into the users table the correct way, and taking into account that way, you come up with a scheme for checking to see if someone is properly authenticated or not. The two have to go hand in hand, right? If you don't know how this stuff was used, then it's not possible to check for authentication, because what you're given in the program, as Nick was asking, the person enters clear text when they enter password. That's correct. So how do you go from that, perform the right series of operations to compare it to what's stored? Only if you know how it was stored can you do that, right? So, because you got to basically repeat that process in order to make stuff work. So what we're going to have to come up with eventually is a function that is capable of adding a user, and then another function which, if you're given the username and clear text password, you can authenticate and see that that actually is the correct password. Okay, so before we do that, let's go ahead and write a script. And what this script is going to do is just call a couple of these functions. Now, for the script to run, we can't be on the PostgreSQL side because it's going to be a PHP script, right, that runs this. So what we'll do is put it inside our project 1 folder just as a test. Okay, so let's do that. All right. So if I go back up to docs and then inside CENT280 and then project 1, since it's inside CENT280 and that gets mapped to be the web document root, then this certainly is something that is inside the web document root. We can run PHP on it. It maps to basically the PHP Apache container. Okay, so we could run it in the web browser. We could also run it from the command line. Okay, in fact, we have such a script right here, and this one just checks to see if you can connect. Okay, now, when it includes helpers.php, helpers.php has these extra functions now. So we could try to access it. Okay, so since we already have this script, and we could not reach this part of the program unless we actually connected. So that means a couple of things. We were able to read correctly the contents of helpers.php. It also means we connected to the database, which we may or may not want to use, okay, but it at least gives us that option. Okay, so how would we use something like do hash? Okay, this is how we would do that. Okay, so I'm going to say okay, it's actually that simple. I'm going to put a new line character, so if I run this from the command line inside the PHP Apache container, then it'll say connected successfully, then it's going to show the hash, then it'll put a new line character so the prompt comes out back on the next line, right? Okay, so I just add those things in there. I come to my second container. It's not inside the PHP Apache container yet, but let's put it in there. Okay, so Docker compose, I'm gonna execute inside the PHP Apache container, the bash program. Okay, and when that starts up, it's gonna show right at the web document root. If I do an ls, and I can change into project 1, I do another ls, there's my testconnect.php. What I do is check to see if I introduced any syntax errors in the couple of lines of code that I just added in. No syntax errors. Okay, so then I'm going to run the program. Okay, and here's this long string like this. If you had incredible memory, you would see that this is exactly the same string that was generated from the Python program using #li. Okay, so you gotta take my word for it. Okay, but you could actually copy and paste and then do a comparison between those two. But they're the same string. Okay, so SHA-512, right? That algorithm for producing that hash, right? It's a set thing. So even in different programming languages, you get the same result, which is very important. Otherwise, our authentication schemes are not going to work. Now, let's do this. I'm going to, on the next line, I'm going to echo and I'm going to say make salt from this incredibly complex password test. Okay. So it's not a very good password, but that's okay. So I'm going to run the make salt function so that you can see how that one works. Okay, so I return to my second shell here, and I run the program again. Okay, so here, this first one, you might recognize at least the first few characters. That's calling do hash on test. The second one is calling make salt on test. Obviously, they're not the same. That's because use the time function, return the current date and time to the nearest second, concatenate it with test, and then call SHA-512 hash on it, so it's not the same. So if I hit an up arrow and run it again, do hash of test returns the same thing, but make salt is different. Why? Because that's not the same time, right? I ran it a little bit later time, so different string gets concatenated onto test, so I get something different. Okay, so let's do one more test. Okay, so I'm going to call the make encoded pass function. Okay, and so what you see are three different strings. Even though the text that we're using is just the same, T-E-S-T, all lowercase. If I run it again, and you look at the salt and the encoded password, they're different from what we have above, because both of them contain somewhere within there, right, the time, the result of the time function. So those things, so if this is my encoded password, it's a doubly hashed, randomly salted password. To make things work, okay, when we store stuff, we have to store, in addition to storing this, we have to store the salt that was used in order to produce this encoded password. Okay, so if you look at the code for this thing, right? I need to store the salt that's generated this way, okay, along with the encoded password to be able to authenticate. So I need to store two things. So let's go back. While I'm on helpers.php, I'm going to click on open, and then I'm going to open up init.sql. Yeah, I do that when I was clicked on helpers.php, not testconnect.php. Because if I was on testconnect.php, I hit open, it's going to be the other folder, right? So that's not the correct location for init.sql. Okay, so now some of this is going to start to make more sense. Okay, so of course, first name, last name, email, okay, that's all right. Password, why would we store the password? Well, we're not going to, okay, so that there's just a dummy field just to throw people off. But we store both the encoded pass and the salt, because I need both pieces of information to do authentication, because the salt is randomly generated, right? It depends upon the time. So 1 second later, I do the same password, the original password, the encoded password will not be the same because the salt will have changed. Okay? All right, so we need to store both of those things, and then so we're going to start looking at. Watch my time here. I want to give you folks some time to finish up Lab 5, although some of you have already completed that. Okay, but let's get a start into thinking, okay, how would I add into the user's table? All right, so I got test connection, and although I could try to test some stuff out there, and I'm going to put some function inside of here that I'm going to call, that maybe is not the best place to put it. Okay, so well, actually, just for testing purposes, I suppose we could do something like that. Okay, and then eventually take out some of the code from there, from Test Connect, because that actually is inside the Apache web root. So we've got to remember to remove it. All right, so let's start thinking about how this should work. All right. So here is a function, I'm going to call it add user. In order to add the user, I'm going to need to have several pieces of information. So if you look, I'm going to ID, that's okay, that's automatically generated, but first name, last name, email, a password, and we'll use the email as their username. Okay, so that's like their username. And then the password, we'll just say password. Okay, so I'm going to put my first parameter, I'm going to call it $FN for the first name, $LN for the last name, $E underscore mail for the email, and that's their username, okay, and then $PASS for their password. Okay, so what am I going to do? The first thing I'm going to do is I want to connect to the database. Why? Because I need to actually insert, right, into the users table. So I'm going to go $PDO equals connect. Okay, and I'll say if not $PDO, in other words, I don't connect, then I'm just going to call return. So that means the function returns without doing anything, right? Okay, then what I'm going to do is start setting things up so I can actually perform a SQL query, an insert query into the users table. Okay, so let's start looking at what that might look like. Okay, so we'll start off like this. I'll go $SQL equals, and we'll start coming up with our insert query statement, right? So insert into users, okay? Insert into users, right? That's the table name. Then we have to put all the field names that we want to store something into, okay? So we want to put something into first name, last name, email, salt, and encoded pass. Okay, so let's put those things down. So first name, last name, okay, and it's getting kind of long, so I'm just going to concatenate this on. This is part of the same string. First name, last name, email, oops, sorry, email, then salt, and encoded pass, and then values. Okay, so let's double check. First name, first underscore name, last underscore name, E underscore mail, salt, ENC underscore PASS. Let's make sure we got the field names correct, right? So first name, last name, E underscore mail, password we're not going to store, salt, and encoded pass. That's what we need to store. Okay, so those values we want to put in there. And then what we're going to do is use what we call placeholder text. Okay, so you don't have to put colons in front of it, but that's kind of the convention. So I'm going to put colon FN, and that's the placeholder text for the first name, colon LN. Okay, don't put a space like I just made a mistake of making. Okay. Okay, colon LN, then colon email, E underscore mail, comma, then we need the salt, so colon salt, then colon ENC PASS, And then let me hit a few returns here. And we'll get rid of those extra returns later. All right, so let's look at our insert statement. Insert into this table name the list of field names that we want to insert. We want to insert first name, last name, email, not password, salt, and then coded pass. And we're going to pass it the following values. And if you look at these values, you might start thinking back to, oh, when we did SQL inserts before, insert queries, if it's a string, we got to put single quotes around it. If it's a number, then there are no quotes around it, right? And if you look, I don't have anything that looks like single quotes on any of them. That's because PHP PDO, okay, this object will take care of that for us, okay, when we get this to work. Okay, so we got our SQL string. Then what we're going to do is, okay, we're going to create a statement. Okay. So here's a variable, I'm just going to call it $statement. That's because what we're creating is something that, in terms of database terminology, is called a prepare and execute statement. And when you do prepare and execute in all the many different languages that deal with databases, okay, that's there to prevent SQL injection. Okay, so when the user is allowed to enter stuff on a web page into a text box, okay, they could enter stuff in there that will run as actually an SQL command, and you don't want that. And when that happens, that's called SQL injection. If I use prepare and execute, that process of executing will filter out any of the characters that are no good. So things like single quotes in the SQL command, it takes those out by putting a backslash in front of it. So it treats it as a regular single quote, okay, not something as breaking apart part of the SQL command. Okay, so that's what it does. So we're going to basically make it use a filtering process, and in order to do that, we gotta first assign values to all these placeholder variables. And the placeholder variables, by convention, you start off with a colon, okay, for the names, although that's not strictly required. That's what I always do, because then I will never mistake the name of my placeholder variables for like a field name or some other PHP variable that maybe sounds like the same thing. Okay, so this is how we set it up. It's a kind of involved process, but that's okay. You only have to do this and test it once. Okay, I create an empty array called $myArray. You can call it whatever you want. It's just, I use that all the time, and because when I'm doing web programming, I use the same name for that type of thing every time, then I get used to typing it, and when I look at my code, I have less errors because I use the same name for the same type of thing. Just like in Python, when I would split a string and create a list, I always call it tokens. Same thing, I'm just using the same name over and over. Those of you who didn't take Python from me, that's okay. You don't know what I'm talking about there, but don't worry about it. Okay, so here's my first placeholder variable, fn. Huh? Okay, so this array is what we call an associative array. Associative arrays, instead of referring to things via an index, index 0, 1, 2, 3, you put a key and then you just assign the value. So I'm saying within this array, okay, with this name :fn, associate the following value. Okay, so what it's going to be is the value of the parameter $fn that got passed into this function. Okay, so whatever they pass as the first name into this function, that's what that's gonna be set to. I'm gonna be doing the same kind of thing for the other placeholder variables. Okay, so ln is $ln. Okay, so you can kind of see why I use that colon with my placeholder variables, because my parameter names, right, those have the dollar symbol, right, but they have fn and then, oh, I put lf, what am I, ln, sorry, I typed that wrong. Okay, so that way in my mind I don't confuse the two, right, the ones with the colons in front, that's my placeholder variables. Okay, the other ones, those are the names of my parameters that are passed to the function. Okay, and then just be careful, make sure you spell the variable names correctly. Okay, so I got the first three set. The next one that gets put into there is going to be the salt. Okay. Okay, now, this one we have to compute, right? So the way that we compute this is we call do hash, well actually no, we create make salt, right here, make salt, from $pass. Okay? So I created this function earlier, right, just above this, make salt. I pass it whatever they put in as their password. Okay, so right here, this is what they put in as their password. And I call make salt on it, and then that's my salt right there. Okay, now, let me put in an extra line here. Okay. What I'm doing is I'm storing this value. And actually, I don't need this line, but I'm only putting it in, so this part right here, this is 5 characters. It's shorter than typing this out. Okay, that's the only reason why. So it's just for convenience only in my next step. Okay, there's my placeholder variable. Okay, and what I want to do, okay, is I want to essentially be doing what make encoded pass would be doing. Okay, and so here, but the way that I'll do that is I'm going to put $pass right here, dotted with, concatenated with $salt. Okay, a little bit different from what I had right here. Yeah, in fact, let me change this. I'm going to change this from what I had, and I'll show you why in a little while. Okay, the reason why I changed it is before I was calling the make salt function. Okay, so when it does the do hash, it concatenates onto the end of the password by calling make salt. Okay. Now suppose you had this on a server, and the server for some reason was really busy doing a whole lot of stuff, and so that there was a delay time between when you make the salt and then when you call make salt again inside of this in order to calculate the encoded password. Then let's say 1 second had elapsed between the call to make the salt and then the call to this. In that case, then the salt is not correct anymore. But if I change it this way and I say, okay, I'm going to actually pass it the salt, then what I can do is I store the salt that got used here, and then I pass it to make encoded pass, and then basically then it will have an encoded pass that uses exactly the same salt as the salt that's going to be stored inside the database. Okay. Now, normally, if I call this and I put make salt here instead of actually passing the salt to it, the time between when those two things are running is going to be a tiny fraction of a second. So it's highly unlikely that the salt that's stored is different from the salt that's used to make the encoded pass. But to be just careful, just because maybe just by chance, you were right on the edge of like going to the next second and went to the next second, or the server is running really slow. So while it's doing this stuff, it actually takes time to execute those things. We remove that possibility, okay, by doing it like this. All right, so I set up my array, and then what's left to be done is I go statement, execute using the values inside of my array. So this statement here, what it does is that you plugged in all these values into the array, and then when you call execute, running it on that SQL statement that you use to prepare the statement, that's when the filtering process takes place. That's how you block SQL injection. Okay. SQL injection used to be the most commonly used way to attack web pages that have this type of stuff. But you can see it's really, really easy to avoid SQL injection in PHP, because you just prepare the statement, then you just execute it, you use these placeholder values, it filters all the placeholder values, SQL injection is blocked. So you see how easy it is once you have certain amount of know-how, and then so it seems almost criminal that SQL injection still succeeds to this day, but that's because knowing about security but not understanding web security per se can run you into trouble. Okay, so let's say you have a network administrator who's never done web programming in their life. They won't even know to check with the person putting code on their server, did you block SQL injection, right? They don't even know to ask that. Okay, but they should know, because it's something that's a big problem if you don't block it, but it's really easy to block it. It's just simply you do prepare and execute. That's all. That's all you got to do. Just set up with the correct syntax, and then that basically should work. Okay, and so after it executes, the user should be inserted. Now, so here you see one of the things that makes web programming a little bit difficult is there's a lot of back and forth type stuff. I create this function, I'm going to test it, right, in this other program. When we're using Docker, it's further complicated, because this thing I'm writing, I could test stuff in this area under PostgreSQL if it were Python, but if it's PHP, I can't test it on the PostgreSQL side. I got to test it here. Okay, so let's do a test. Okay, so let's try it. I'm going to have connection to this. I'll say add user. Right? Add user. And I'll put Jane Doe, and let's make up a email address for Jane Doe, janedoe@gmail.com. Okay, and we'll put a very simple password, Janie, like this. Okay, so if I run testconnect.php, it'll add a user to the database, right, Jane Doe. So let's see, we got to test it out. Don't know if it works yet, right? Got to test it out. So we come back here. This is my PHP Apache area. I can tell by the prompt, because it says /var/www/doc/CENT280. I'm on the PHP Apache side. Okay. So first thing I do is I check for syntax errors. Because even though, right, I didn't change too much on testconnect.php. I just added that line. I want to make sure, right, that I don't have any syntax errors. And then let's run it. Okay, so you see these blank lines here? That's because I added those blank lines just to push the code up higher on the screen. So it puts those lines there. Eventually, that's kind of ugly, so I want to take that away probably. But we're still in the testing phase. That's okay. All right, so oh, so I made a mistake. Yeah. In fact, you pointed out an error there. That's good. Okay, so make encoded path. Let's see. Wait, what happened there? Oh. My mistake. I put concatenation, right? What is not concatenation is the password, comma, and then the salt. Password, comma, and then the salt. Okay, so so then it signaled an error. Did it insert data anyway? Let's check. So I come back to here, and I go back to my first ConEMU terminal, and I connect to the database, right? So PSQL-U Bob-W proj1_db. Some pass, okay? And I'll go select star from users. Oh, it put it in. Did it put it in correctly? Chances are no, right? Because I actually used the function incorrectly. I had one argument by concatenating two things that I should have had a comma separating them. So its stuff is in there, but that's probably not correct. So what I'm going to do is I'm going to go \i init.sql, so it just cleared out that entry. Okay. Then I'm going to go back to this. I'm going to run testconnect.php again, and then, oh, did I not save it? I thought I saved it. Okay, something is wrong with my code. Huh. Okay, so here's, okay, so this is do hash, this is make salt. Oh, okay, I get it now. Okay, so it might not have been storing stuff incorrectly. Here's my mistake, right? So what I should have done is this. So using my test that basically it wasn't working correctly. Okay, So the add user, for all I know, could work correctly. But I don't know that yet. Okay, so we'll talk about why I don't know that just at this point. All right, so I gotta do a couple things. I run init.sql again, just to clear that out. Then I come back here. And I run this again. Okay, no warnings, nothing like that. So I think it's stored correctly. And then, so what I get is this. Now, do I know that it's stored correctly? At this point, I don't, because I don't have another function that can check to see if, in fact, it did get stored directly, right? Because I don't know. And the only way I will know is if I build a function or if I run a query, a kind of complex query, to figure out if it actually is correct or not, okay? But if you look at this, okay, it's supposed to store in the name ID, okay, so ID is 1, first name Jane, last name Doe, email janedoe@gmail.com, password is blank, right? Nothing is stored there. Then salt has this long thing going from here all the way to here, then encoded pass, this stuff going all the way to there. So it stored something, and they're definitely hexadecimal strings, but is it stored correctly? We won't know until we actually generate a function that will allow us to test to see if it's correct. All right, so to create that function, we have to look at add user and see how that was set up in order for us to make a function that will check things. Okay, so this is how we're going to do that. We're going to make a function called check ID. Okay, and for this, I'm going to have a username and a password. Okay, so how is this function going to work? Well, this function has to connect to the database. So once again, I'm going to go $PDO is connect, and I'll say if not $PDO, okay, then we just call return, which means the function ends. Okay, let me push this up a little bit, and I'll upload this afterwards. Okay, so what I want to do is I want to run a query, okay, on the database, and this is how we start that query off. We say, okay, $SQL equals, and we'll say select star from users, right? That's how we usually do, select all the fields from the table, from users, where email equals $user. Okay, so that's my SQL statement to start off. And then what I want to do is I want to run that. Okay, so here we'll go $results equals $PDO query. Okay, we don't worry about SQL injection here, right? We're not inserting into the database. All we're doing is querying, right? Doing the select query on the database. Okay, so what we would like to do, okay, to check this, let's do it in a couple of steps. What we're going to do is just echo $results row count. Okay, so that's the name of a function that we can call on that. All right. So what I want to do, go back to test connect. Okay. Oh, look at this. I already added this user. That's okay. I'll leave it in there. Let me leave that. And then what I'm going to do is I'm just going to call check ID, okay, and I'm just gonna put janedoe@gmail.com. I'm gonna put Jane. Okay, that's how I wanna check it, because if I had this on a page where I asked them to enter username and password, that's what they would enter, right? janedoe@gmail.com for username and Janie for the password. That's what we would be reading in. Okay, so I want to run this. I'm going to call check ID. It's not going to do the full authentication. All it's going to do is display the row count for when I check to see if that user is in fact in the user's table. Okay, so let's give that a try. Okay, so I'm going to run it. Oh no, before I run it, double check. Do I have syntax errors? No, not in that one. So that looks okay. So let's run it. And oh, we got a problem here. Call to memory for. Okay, something's wrong with my code. Let me see. Okay, I don't actually understand what that error message is saying. Oh. Okay, I think I see the problem. Okay. So I forgot to put single quotes around this, and of course I'm not using prepare execute, so I have to put those single quotes in there. Let's see if that's all it is. Okay, yeah, there we go. Okay, so the count is 1. All right, sorry. Missed that completely. Okay, so where I messed up is that $user is username, but I forgot to put single quotes around the string, which I need to, right, when I'm doing the SQL statement. I didn't need it earlier when I do this, because those are placeholder variables, and the execute part, when it does the filtering, it puts in the correct, if you need quotes, it puts it in. If you don't need quotes, it leaves it off. Okay, so I got sloppy here when I did that, and that's what caused that problem to occur. Okay, so it put a 1 there, right? Now, suppose I call check ID on John Doe okay, right after that. Okay, so I just put this in. Now, I'm gonna run it again. And what you see is when I did it for janedoe@gmail.com, the row count is 1 because it returned 1 result. It returned 0 because I haven't stored John Doe in there. Now, one more question and we will take a break. Okay. This add user function got called several times, right? Because I ran this 3 times after I cleared the database. I ran it 3 times without clearing the database. So if I go into the database, how many users do you think will be in the users table? I ran it 3 times after I ran init.sql, right? So I ran php-f test connect successfully 3 times. So how many users will be in the users table?
2.
3?
3.
3, 2, 3, 1, 0. Well, it won't be 0, right? Well, let's take a look. Okay, so what I'm going to do is I'm going to go select ID from users. So it doesn't display lots, it just shows the ID that's generated. How many users? 1. What causes that? Any ideas? Not add user. Any ideas? It's actually in init.sql. When you make the email have to be unique. If I go add janedoe@gmail, every time I try to do that, once I've done it, it rejects all the other ones. Okay, so you just see it showing up just one time. Okay, so it's this, and that's why you do it that way, because you don't want to add the same user more than once. That's the advantage, one of the advantages of doing something like that. The other advantage, which is very important, is that when you enter in a valid username for someone already in the table, this row count is going to be 1, okay? Not 5 or 3 or 7 or whatever. Or if the user is not in the users table, it'll return 0. And that's really important. Okay, been going on a long time. Let's take a break for about 5 minutes and then we'll come back and then try to finish off the check ID. Okay, and then I'll give you some time to complete lab 5. Okay, and I will upload this afterwards, so in case you ran into problems with it, you can get this. Okay, remember when I upload this stuff, I have to compress it, right? Because I can't put anything that's named PHP up there. All right, so now that I kind of figured out that the count will be equal to 1 if the user is in there, I can do the following. Okay, so I go if $count is not equal to 1, I'm going to return a -1. Okay. So okay, so the first part of my selection statement, I'm going to check to see if the count is equal to 1. If it's not, I'm going to return a -1. That means the check ID function will return a -1. What we're looking for is when it returns, we want it to actually return the ID. So if the Jane Doe was the first one, it will return a 1. If we had John Doe in there, it would return a 2 and so forth. And it'll only return a number greater than 0 if it's a valid user ID. And because the user ID is always going to be one or more. Okay, so let's continue with this. Okay, so if it's equal to 1, then I want to basically look a little bit more carefully at the results, right? So here's what I want to do. Okay, and that's why I want to get our results, and then I'm going to actually fetch the results into an associative array called $row. Okay, and since we're still developing this, I'm going to just do a var underscore dump, variable dump on $row. If I just have a single variable, I want to show the contents of it, I can just go echo and put the contents. But if I do echo and the variable is an array, then it's just going to show the word array. It's not going to show the contents of the array. But var dump actually lets you see the contents of the array. And so let's take a look at this. Okay, so here's the array returns. So when we check for Jane Doe, okay, then the ID is 1, which is what we suspect, but then we got Jane Doe, we got email, password is null, the salt is this long string, and the encoded pass is that long string. Okay, so we want to make use of those two things basically to check to see if it's authenticated. And then if you look, because it was also calling, let's see, no, that's it, that's what we're calling right there. Okay, and it didn't return anything for this except the -1 at the very end. Let's see, I don't know, I didn't see the -1, but it should have returned a -1 in there someplace for the John Doe one, because John Doe, the username, doesn't exist yet. Okay, well, anyway, let's fix this. All right, so let me comment this out temporarily. Okay, so we got the kind of the result, so we're going to say is this. Okay, so $salt is equal to $row. It's an associative array. And you can see the name of it is salt. Okay? So I got the salt that's stored, that's a stored salt, and I need the stored encoded password. Okay. So those two values are the ones that's stored, because we're getting them from the row that's returned when we run this query, right? So we go select star from users where the email matches the entered username. So now we're getting the stored salt and the stored encoded password. All right. So now what we have to do is we need to check the following, right? So think of what we do in add user now, right? When we store the encoded password, okay, what we're doing is we're taking the password, we're concatenating it with the salt, and that's how we create the encoded password. Okay, so that means the following. If, okay, I do hash on the past password, right? The past password concatenated with the stored salt, okay? If that's equal to the stored encoded password return the ID. Else, return -1. Okay, so let's try to go through this and then follow the logic on this. We're going to go run a query. Select star from users where the username matches the past username. Okay, where email matches the past username. We run the query. If the resulting query doesn't return a 1, then the username is not in the users table, so just return a -1. Okay? If it returns a 1, the username is correct. It's in the users table. So what we do is get from the results the associative array that stores all the results. We get the stored salt. We get the stored encoded password. And then we do this check. If I call dohash on the past password, the one the user just supplied, concatenated with the stored salt, the stuff that's in the database, I compare it to the stored encoded password. If it's the same, then I'm going to return the ID for that user. Otherwise, return a -1. Okay, so when I run it, if this is working and it stored everything correctly, it should return a 1 for Jane Doe because Jane Doe's user ID is 1. Okay, so let's try that. Okay, and what happened? Oh, all right, sorry. That's why we didn't see anything earlier. Okay, so I need to echo the return result, okay? And in fact, why don't I just add this one back in? Okay, earlier when I called check ID, because there was either had a var dump or an echo, then that's what displayed the output. But then now it doesn't do that, it just returns the value. So I need to echo whatever gets returned to the screen. So what we hope to see here is that it'll show a 1 for Jane Doe, and it'll show a -1 for John Doe, because John Doe is not stored yet in the database. All right, so let's give that a try. Yeah, 1 for Jane Doe, -1 for John Doe, because John Doe is not stored. Now, we know that it was stored correctly, because using basically exactly how it's supposed to be stored, we verified that the username was correct. Okay, so what? Let's do another test. Here's Jane Doe. I'm going to change her password. Okay, so that's an incorrect password now. I'm going to run the program again, and I should get 2 -1s, right? So the username exists, but the password is incorrect. In John Doe's case, the username doesn't exist, that's why it returns a -1. Okay? You could, I guess, theoretically, well, let's not make it theoretical. Let's do it this way. Okay, so we'll return a -1 if the user doesn't exist, and a -2 if the user exists but the password is wrong. Okay, so if I run it one more time, this is bad username. Sorry. Correct username, bad password, bad username. Right? So you could tell the difference between the two if you put it up like this. Okay. So, that was actually quite a bit of work to do that. I'm going to get rid of the extra lines at the bottom. And I'm gonna upload helpers.php and testconnect.php. And when I do that, I gotta be kind of careful. Okay, so here, okay, so here I copy docs. I'm gonna paste it on my desktop. And I don't care about all these directories. Okay, and inside the CENT280 directory, I don't care about PHP test or test or any of these. Now remember, I made a copy of it, so I'm not destroying my original one. So I got CENT280 inside of there, just project 1, that's testconnect.php. And then inside of docs project 1, that's where I have helpers.php and the testhash.py and everything. Okay, so this one is cleaned up. I'm going to send to a compressed file, and that's docs.zip. And let's rename this, and we're just going to tack on 0225_2019. So we know the date of this zip file as well. Then I go back to Laulima, and we have this folder, and I'm going to go upload files, and there it is. I'm going to upload that zip file. Okay, so the two files that I worked on today, helpers.php and testconnect.php, those are inside of there, right? You gotta dig into it a ways to find it, but then those are located in there. Remember, we gotta store it as a zip file, right? Because PHP files will be clobbered by Laulima. You have basically nothing in there if you upload them as PHP files. Okay, any questions? All right, so I'm gonna stop there. If you're still working on Lab 5, go ahead and ask questions if you have any. So I'll be walking around, and then you can get to those two scripts in case yours didn't work out, or if you just have a simple error message you want me to look at it, I'll take a look at it as well.